Welcome to the Math Club for today. It is my pleasure to introduce Bill Calkin, who is going to tell us about recreational mathematics.
Next week. Unfortunately, we're having Eliza Gallagher here as well. We do a regular double act, but she's had some other things along that need taken care of. So it'll just be me, I'm afraid. Everybody makes sad noises. I'll relay that to Eliza when I next see her. Today is October 18th. And that makes this the Friday closest to October 21st this year. Yeah, you did the calculations in your head. Recreational math, right? And every year around this time, people around the world celebrate the life and the work and the inspiration brought to us by Martin Gardner. Now, some of you are too young. Jim? No, you're old enough. You might remember Martin Gardner. Most of us are too, I'm not, but most of us are too young who have experienced reading Martin Gardner's columns when they came out. Martin was born on October 21st. He would have been 110 on Monday. He died at the age of 95. Pretty good innings. 98 books or so, 100 books. I lost count. I have about somewhere between a third and a half of them. And many of them are filled with columns that he wrote for the Scientific American. Any read Scientific American these days? Anyone? Oh, that makes me sad. I don't either. That makes me sad too. When I was a kid, my father had a subscription to Scientific American. Did your dad have a subscription to Scientific American, or did you have to buy it yourself?
I had to get it myself. That's more controversial.
So I was lucky. My dad was an engineer and was fascinated by everything in Scientific American. He had a subscription. And when I was old enough to read, he let me read it. And every month there was a column called Mathematical Games by Martin Gardner. I'll tell you a little bit more about that in a couple of minutes. Martin Gardner is responsible for probably about half of the people in my generation who became mathematicians, who are then becoming mathematicians, because we read stuff in his column. And it was amazing. He taught us about some graph theory, the four-color problem, the four-color theorem. He taught us about hexaflexagons. He taught us about P versus NP. He taught us about RSA encryption algorithm. And we read about this in words we could understand because it was brilliant communicator. Have any of you read any Martin Gardner? Do you remember one in particular?
I just read his book, Neil's Life and Other Mathematical Amusements.
Okay, so one of his 98 or 100 books. Martin was a fascinating individual. He's probably the most influential person in American mathematics of the last century, because of the fact that he inspired so many people within 10 or 20 years, either side of my age, to become mathematicians. The greatest friend that mathematics ever had. When you go to his Wikipedia page, Martin Gardner, American mathematician. Would you care to guess where he got his PhD? Would you care to guess where he got his math degree? He did. Would you care to guess where he took his college math classes? He never took a single class beyond high school in math. He had a degree in philosophy from the University of Chicago, but was not made to take a math class. And yet he was the most influential mathematician of the last century. How could this be? And it's a serious question. I want a serious answer. Or it's a fun question. I want a fun answer. This is serious fun.
Intrinsic link between philosophy and math.
There's certainly an intrinsic link between philosophy and math, although the philosophy he studied was probably less mathematical than some.
Maybe mathematics is not about taking classes.
Maybe mathematics is not about taking classes. What is it about?
I have no idea.
I'm hoping one of these days I'll figure it out and be able to do something with myself.
Is it like related about the age, about the time, because I've known Chomsky, who is not a mathematician, but he has a theorem in mathematics. So it's about their culture at that time.
So maybe the culture at the time. So Martin was born in 1914, and the culture at the time was not particularly mathematical. There was an emphasis on mathematics in popular culture and in education that started in the weeks after I was born. Yuri Gagarin circled the Earth 2 weeks after my birth. Nice of him to celebrate it. He got the timing off. And suddenly everybody in the US got terrified that the Russians were going to win the space race. And so we needed lots and lots of people to do important math like computation. We didn't have computers to do the computations. So we needed people who were really good at doing addition and subtraction, multiplication and long division accurately. And we ended up training them in how to do that in high school and destroying the minds of a generation in the process. People end up thinking that math is all about long division. Math is about so much more, but in particular, math is about curiosity. And the reason that Martin Gardner could become the most influential mathematician of the last century is that he had a curious mind and he had an amazing ability to make friends. And he also had some connections and was able to make friends with quite a few people who were themselves amazing mathematicians, people with undergraduate degrees in mathematics, like Richard Guy, and PhDs in mathematics, like John Conway. And Martin wrote to them, and they wrote back. And it got to the point that whenever one of them heard something new in mathematics, oh, the bunk bed conjecture has been disproven, Martin would write a column about the bunk bed conjecture being disproven. Anybody heard about the bunk bed conjecture? Apparently it was disproven last week or sometime very recently. I have not looked up what it is. It was not a conjecture I was familiar with. But Martin would get a phone call from John Conway or Richard Guy, and they would say, here is what this is. And Martin would say, well, I don't understand that. Can you put it in terms where I can explain it to the layman? And he had an amazing ability to get brilliant mathematicians to explain things to him in such a way that he could make it his own and explain it to the layman. He was also a great writer. He's famous for a quote along the lines of, the best thing you can do to a young mind is put a puzzle in front of them. Be it a chess puzzle, or some mathematical puzzle, or something that's going to engage their mind and make them think, not because you're telling them to think, but because it's fun and it's challenging. So I want to do a quick advert This is the paid commercial break. I paid precisely 0 to do this. In fact, I had to buy the book. Oh, I will advertise this. It puzzled me twice. It came out this week. This is published by. Can't read who it's by. That's enough to find it on your favorite ultra cheap mega book selling site. Alex is somebody I know not well, but enough to have really pleasant conversations with whenever I see him. He's a British journalist who writes a puzzle column every 2 weeks for The Guardian. And really comes up with presents really interesting puzzles. I don't know that he comes up with them. I know that very often he is fed them by somebody else. This book in particular is filled with puzzles that people get wrong. Mathematicians even get wrong. So I recommend that you get this, puzzle yourselves, figure out why you get the puzzles wrong, and understand why you were wrong, that really worked. So, end of paid paid advertisement for Alex Bellos. He's a wonderful writer. Check him out in The Guardian. Every other Monday, he has wonderful puzzles. He'll put the puzzle up early in the morning, British time, and then around 1 o'clock British time, so 8 o'clock in the morning, our time, he puts up the solution. But you can see the page without the solution, even though he's put the solution up. So, what's recreational mathematics? Jim, stay silent. Any ideas?
Mathematics for fun.
Sorry?
I said, you asked what was
Recreational mathematics. And you said?
mathematics for fun?
Mathematics for fun! Well, that really narrows it down, doesn't it? Pratika, what sort of math do you find fun?
Statistics.
Statistics. So statistics is a great example of recreational mathematics if you find it fun, right?
Yeah.
Okay. What sort of math do you enjoy?
What I'm good at.
Oh, so recreational mathematics is math we're good at.
Probably not, that's probably not true. Hard to enjoy something you're not good at.
It is hard to enjoy something you're not good at. It's not hard to enjoy something you're not good at yet. It's hard to enjoy something you stay bad at.
Yes.
Yeah? Recreational math is an insult. Oh, that's just recreational math. Oh, you're playing with puzzles. Oh, that Rubik's Cube, that's just recreation. But the Rubik's Cube leads to serious mathematics, some serious study of group theory. It's a great way to look at conjugacy classes in groups. It's a hands-on thing where you can actually see the actions being applied to a physical object and really understanding visually what's going on with some transformations that are really group operation.
And it took years of research to figure out God's number.
And it took years of research to figure out the furthest you can get from solved. in terms of the shortest path from a configuration to the completely solved cube. What is God's number?
Depends on how you count the turns, 20, 26.
Right.
Yeah.
26, okay.
Yeah.
Was that Thomas,
I don't know who it was.
Rookie,
but
you
Matt might
found out?
know, actually.
Wait, who is it?
was it Thomas Rapicki?
Yes.
Okay.
Don't have heard.
So Thomas Rapicki is an interesting character. He does math for fun. Definitely. He's I think, computer scientist by training and by employment. But he spends time going to the Gathering for Gardner because it's fun. It's about recreational mathematics, and he can talk to people about really smart ways to compute God's number, or better algorithms for computing positions in the game of life. Or, well, those are the two things that I've heard him talk about. So the Gathering for Gardner, which I just mentioned, is a conference every 2 years. It is the most fun conference I have ever attended. I've been going since 2009, I think it was, first time. And it's amazing in terms of the intellectual engagement, the caliber of the thinking, amongst a bunch of people who are there to celebrate Martin Gardner. There are recreational mathematicians. There are serious mathematicians. The intersection is non-trivial. There are mathematicians who are dead good, and unfortunately there are mathematicians who used to be good but are now dead. But used to go regularly. There are artists, people who do mathematical art. There are magicians. Martin Gardner, I've been telling you about his writing for Scientific American. He also wrote for Genie magazine a lot, a regular monthly column. And within the magic community, if you mention Martin Gardner's name, any professional magician my age, there's a better than 50-50 chance that they will say, yeah, he's why I became a magician. His writing was so influential. He inspired people in their 50s and 60s and 70s to become magicians. And then there are skeptics. People who like debunking Uri Geller, for example. I have to explain who Uri Geller is, don't I? Oh, anybody here heard of Uri Geller? Jim, surely.
Yes, I've heard of it.
Wait. So Uri Geller gained some fame in the 70s, late 70s, I think. He was everywhere on television for a while, bending spoons. With his mind, so he said, and with his mind controlling his fingers, and certain other techniques, and doing mentalism, reading people's minds. And Martin Gardner and the amazing Randy and a bunch of other people devoted their time for a significant number of weeks and months to debunking Uri Geller by showing that they could do exactly the same things as he could do, except they said, we're faking it, and he said it's real. How do you tell the difference? But he's faking it, and they're doing the real. But they're telling you how they do it. They say, this is true. So, I mean, instead of saying recreational mathematics is fun, which I agree, and I think mathematics is fun. Hopefully, in an audience like this, there's significant number of people who do think math is fun. Can we get some more examples of what might be considered recreational mathematics? Sorry?
Calculus.
Calculus is usually regarded as a serious topic, invented by Newton, or Leibniz, or both,
Or neither.
or neither. If Archimedes had had the appropriate technology, what do I mean by the appropriate technology? Notation. Notation is mathematicians' technology. Archimedes didn't have the equal sign. Archimedes didn't have a plus sign. He didn't have a way to represent multiplication. He didn't have notation to write things down. Had he had notation, he might well have invented calculus 1600 years before Newton. He didn't, but he invented a lot of the ideas. The method of exhaustion was really very much taking limits. So yes, Newton did some marvelous stuff, as did Leibniz, and they were building on the work of others.
Now you make me think about the question, is mathematics is a discovery or an invention?
Oh, let's take a rabbit hole. I love rabbit holes. Is recreational mathematics invented or discovered? Or is mathematics invented or discovered? Does mathematics exist?
Yes.
Yes, okay. We have a very firm, yes, mathematics exists.
Sorry.
Tell me your name.
Garrett.
Jared? Jared or Jared?
Jared.
With me. Okay.
Jared.
Oh, Jared. Okay. So Jared is standing up firmly for the existence of mathematics. That's great. Where does it exist?
It depends on if you're asking
Well, I'm
from
asking
a
you.
logicist perspective, or from an empiricist perspective, or from a nominalist perspective. I mean,
I'm asking for your perspective.
I think anytime that a mathematical object is instantiated by a person that has existence, whether not physically, I don't think that the chalk on the board that you write the 2 with or write the circle, I don't think that is the number 2, but I think we all have a strong enough understanding of what the number 2 is or what a circle is, that it has to exist in some sense.
You picked the right rabbit hole there.
So what is
Very
two-ness?
platonic.
What is two-ness? What is the intrinsic concept of 2? I mean, you're saying there's something intrinsic to 2 that we understand.
I think at the lowest level, I think people understand 2 by grouping the physical instantiations of what we would consider 2. They look at 2 things, we think that's 2, it's
Okay.
2, and
Okay.
then it takes.
I am pretty good at looking at a set of oranges and saying there's 2 oranges going, and getting it right. Most of us are.
Getting it wrong as well.
Yeah, I'm a mathematician. I get arithmetic wrong all the time.
It also
So-
is why.
I can actually recognize 5 oranges pretty well. And on a good day, I can even recognize 7 oranges or 6 oranges.
That's crazy.
Yeah, I can
barely
barely,
get
it's nuts.
the-
I'm really good. I'm a mathematician. But if you group 16 oranges in 4 rows of 4 lining up, I can recognize 16 oranges. Charlie is just astounded at my ability. How? I can spot certain patterns, but if you present some number of oranges, somewhere around 15, 16, 17, 18, in a relatively jumbled position on a table, I can't look at that and say there's 15 oranges.
Psh, not a real mathematician.
Can you?
No.
So, I mean, humans are better than crows. Crows can count to many. 1, 2, 3, many. Some crows can count to 1, 2, 3, 4, many. Many means something different between those 2 crows.
Already better than me.
Yeah, well, they're counting crows. So what does 15ness mean? 2ness, we can perceive 2. It enables us to build up a concept of 2. What does 15ness mean?
1 more than 14 is.
No, great answer. Great answer. This is essentially defining numbers by successive generation of the numbers. You start with nothing, you generate the successor, which is 1. You start with 1, you generate the successor, which is 2. By the way, is 0 a natural number?
No. Yeah.
Yes?
No.
No. You're wrong, Jim. Natural numbers, to me, are the counting numbers. And they count the sizes of finite sets. And the empty set has nothing in it, it has size 0. So what's your rationale for
I always
excluding
write n sub 0.
it?
Right, so if you put 0 in the natural numbers, I can't use that symbol anymore, and I'm kind of attached to it, so.
See, I use n greater than 0 for the numbers
Right.
1 and above.
The important things.
Yes. So we have to sort of develop some sort of mechanism for dealing with numbers that are outside our range of physical experience. Because we don't generate the mental connections that we have with 5 oranges for 15, a group of 15 or something. Unless we group it in rows of 3, 5 rows of 3 or 3 rows of 5, I can recognize it's 15. But once we get to more than 5 rows, more than 5 columns, in 3 or 4 or 5 dimensions, I can't perceive these things. I can count.
Are you familiar with Descartes' favorite example for this?
Oh, please give it to me.
Well, in one of his meditations, he talks about can you distinguish between a chileagon and a circle? And the chileagon is like a 1,000-sided polygon. And that's like his favorite example for this.
It's great. I mean, you can almost do the 17 gon. You draw a 17 gon and squint, and it looks like a circle. Particularly the one on Gauss's tombstone. Yeah, that's the 17 gon. It's etched so poorly that it is indistinguishable now from a circle. So let's ask, does mathematics exist? You say absolutely yes, and I say where, and you say in every instantiation of an idea. Is that a satisfactory answer? Okay, Ben says yes. Matt's looking a little bit inquisitive. No, skeptical maybe.
It's not my area, but I've heard people argue who are in the philosophy of mathematics that mathematics is entirely associative and constructive. And if I'm not an expert, I don't want to say no more than the people who study this.
How can you talk about something that, how can you say that something exists when you say that same thing doesn't exist? So if we're talking about mathematics, doesn't it imply that mathematics exists?
Oh, so the fact that we're talking about it sort of presupposes the answer to the question is yes, it does exist. Certainly. I mean, I teach math classes. It's better down when it exists.
But I mean, it's hard to say it exists or not if we don't define what is mathematics.
Oh, what is mathematics?
I think that's-
Well, let's start with
It's not even
recreational
clear to me
mathematics. What is
what is-
recreational mathematics?
It's not even clear to me that we've defined what existence is.
No. So I love asking this question of undergraduates in particular. Because I can't predict what a class is going to say. Right, whether the class as a whole will come down on the side of yes, math exists. With math majors, it had better exist. Or no, math doesn't exist. But as soon as they come down on one side, I can argue for the other. And it's always a class. Has anyone had this class from me? I don't think any of you have been in 3600 with me
Oh.
when I've done that. Oh, yes, you have, Pratik, haven't you?
Yes.
Did your brain hurt that day?
Yeah.
Yeah.
I think we all collectively agreed yes that it does exist because that's our degree. Like we're getting our degree in this, so like it better exist.
Yeah, the conclusion by desire.
Have you ever gotten like a different response? Like no, it doesn't.
Yeah.
Oh.
Yeah,
How
yeah.
is
And if
that?
they say no, it doesn't, I'll ask, well, suppose we encountered an alien race come from another galaxy. They were able to build spacecraft that could travel fast enough to come and visit us, and their civilization have probably been around a lot longer than ours if they were at that stage. Would they have had to have some understanding of mathematics that we would understand? Would they have a sense of integer? Would they need to have a sense of magnitude, of geometry? Could they do engineering without some version of math that probably has some intersection with our own? And I am sufficiently biased as to believe, well, maybe we will be able to understand some of what they do, but hopefully they'll be able to understand some of what we do. And how would we initiate conversation, communication between two very, very different types of beings? Well, probably we'd start by counting. We'd probably start by identifying certain numbers, like 1, 2, 3, 4. And maybe we would identify that we understood that some numbers could be laid out in a rectangle, meaning that they have a non-trivial factorization. We know 3 by 5, we have 15, we can lay it out in 3 rows of 5. So there are 2 choices here. We can continue talking about this. We can go back to recreational mathematics. I'm willing to do either one. So continue talking bullshit philosophy.
Think of philosophy, I think you're arguing that -1 is a natural number?
Not if you're counting the sizes of finite sets.
I'm just dying to know if anybody's ever accused to take one of your exams when the grounds of math don't exist.
No, they know I'm so. No point to confusing these. That's like a natural
The
number.
combinatorial. No, the combinatorial, you're supposed to defend the fact that -1 could be a natural number.
No, -1 can be an integer.
Well,
We have naming
convention of
standards.
It's just a definition.
It is a definition, and Jim and I differ on the definition we choose to use. He's wrong, but he knows I'm joking. For him, natural numbers are the sizes of non-trivial objects. And the empty set is trivial. The empty group is, well, not a group, because it has to have a one.
Kinda, I guess my perspective is sort of historical in that.
Is 1 a prime?
What's that?
Is 1 a prime?
Oh, absolutely not. I can give you an argument for that.
Well, but was 1 a prime 100 years ago?
Maybe incorrectly.
We could certainly, there is agreement about this.
Yeah, you lose the fundamental theorem of arithmetic.
Yeah, exactly. Yeah, you want your definitions to be such that they are useful. And if 1 was taken to be a prime until somewhere around the end of the 1800s, and then abruptly, better mathematicians, other people decided it should no longer be considered prime because it made things so much cleaner. That decision could be made in Euclid stage. But
We want to talk about recreational mathematics. The Greeks loved primes. They had no use for them whatsoever.
yeah, the Greeks loved primes and had very little use for them, whatever. Egyptians hated fractions, except for unit fractions. Numbers of one form 1 over a. So when somebody says, does math exist? It does lead to the discussion which you brought up of discovery or invention. So I'm going to tell you a problem. So this is, for me, this is a perfect example. How many of you have had the experience of working on something like crazy and you can't do it? Yeah, of course. And then you go to sleep. And you wake up and your subconscious has given you a solution to the problem. Be it a hard calculus question or research question. Nobody? Yeah, I see a few hands sort of hovering. Any of you had the experience that you wake up in the middle of the night with a fully formed solution to a problem, you write it down and figure out why it won't work? When I was writing my thesis, there was a particular result I wanted to prove. And I had to prove that alpha was less than 0.6 something. And I wanted to prove that alpha was equal to a half, whatever alpha. And I remember one night working until 7, getting some dinner, working till 8, getting a glass of water, working till 9, working till 10, 11, finally getting to sleep, waking up at 1 with an idea, writing down the idea, figure out why it wouldn't work, going back to sleep, waking up at 2, writing down an idea, figure out why it wouldn't work, going back to sleep. And this went on the whole night. And I never did get that theorem for my thesis. Actually, about 3 months after I defended my thesis, I was sitting in on a class on mathematical logic at Carnegie Mellon, where I was a postdoc. And in the middle of the class, unbidden, came, oh, that's just, I wrote out how to get this bound of a half to work. Became my first paper. One of the best papers I ever wrote. And a couple of years later, I was packing up, having finished my years at Carnegie Mellon, I was packing up my stuff and moving to Atlanta. And I was going through all these old papers, trying to figure out which ones I wanted to keep, and which ones I really could just throw away. But I'm a pack rat. I don't throw stuff away easily. And I came across these notes from the middle of the night, 3 years earlier. Sure enough, the third idea I wrote down was exactly the one that worked 6 months later. And I was just too stupid in a waking stupor to realize that, yeah, this does work. There's an old saying that it's much easier to prove something if you know it's true. If you know somebody else has proved it. Really easy to prove something that somebody else has proved, but proving something for the first time is actually much harder. I've reproved lots of things. Rational is accountable. Yeah, got a nice proof of that. My first week in graduate school, I met this lovely young woman who was in her first week in graduate school in psychology. And she knew I was doing a PhD in combinatorics and optimization, whatever that is. She had no idea. And she phoned me up and said, my little sister has got a homework problem that she can't solve. And I said, well, I'll tell you what, tell me what the problem is, and I'll see if I can come up with a good hint for her. I won't tell her how to do it, but I'll see if I can ask some good questions that will help her figure it out. Back then, I was a sadist. And so the problem was the following. First, I found that equation. I worked quite hard to figure out a good hint. Well, first, I tried quite hard to solve it. And the chase seemed, I phoned Laura back up and said, look, I can't figure this out either. Let me get back to you. And I was taking a course on combinatorial number theory from Stefan Znam, who was visiting Waterloo that year. And so I worked hard for another couple of days, and then I went to Professor Znam and I said, I've been given this question and I can't figure it out. And he looked at the problem. He said in a very thick Eastern European accent that he would get back to me in the next class. The next class, he comes in with a little book by Shapinsky of mathematics, open and closed problems, Straczynski had tried this problem and he had made very little bit more progress than I had. Basically, he had pushed about higher than I had, but only because he worked a little harder at it. I'd only spent 3 days doing it, and he spent several weeks. It's an open problem. This is called the Erdős-Strauss conjecture. And it's proof that just because you know something is true and can be done because you've been presented it as this is a homework problem, doesn't necessarily mean that it is easier.
Who the heck is little sister's teacher?
Well, so I asked for clarification. By the way, anybody know of Ernst Strauss, why he's significant? Strauss wrote papers with Einstein and with Erdős. So he's the reason that Einstein has an Erdős number of 2. And consequently, I have an Einstein number of 3. Anybody wants to get an Erdős number of 2, write a paper with me, and it'll happen. It's as low as you can pretty much legitimately get these days. If you haven't got an Erdős number of 1 already, you probably can't get it. Well, Steve Butler got an Erdős number of 1 about 6 years ago. Erdős died in '96. But Steve Butler was a student of Ron Graham, and Ron Graham and Erdős had worked on a particular problem that Steve Butler worked with Ron Graham on, and they combined some results of all 3. And Ron Graham was about the only person in the world who could get away with saying, yes, this is a joint paper with Erdős 26 years after he's dead. No, 16. Well, 20 years after he's dead, whatever. Recreational math. There's a wonderful XKCD comic about what would happen if there was a rising of zombies. These mathematicians would go and find the grave of Erdős and get him to sign pieces of paper. So, as far as I know, this is still open. It is a very easy problem to understand. What the teacher did was say, this is an example of a problem of Egyptian fractions, and wanted them to write about Egyptian fractions. This was a lack of effective communication between a math teacher and a student. It's a good thing that never happens now. It doesn't, does it? Your math teachers are all excellent communicators, I'm sure. Right? Except for me. So I wanted to sneak some mathematics in today. But I want to tie this now back to, does math exist? Is this statement that's for which we've asked for a proof a true statement or not? I don't know. I can't prove it, and I haven't been able to find a counterexample either, so I don't know. Is it the case, however, that it is either true or there is a counterexample? Is this a yes/no question? Maybe. Is this
ZF or ZFC?
sorry?
ZF or ZFC?
Does it matter?
Well, maybe you can have a choice to get this, but you know, it could be independent of the accident, right?
Right.
I doubt
If
it.
it's false, how is it false? Unless there exists a counterexample.
Right.
It might depend on what your model of the integers is,
Yeah,
because there are bigger models of the integers than just n. But let's restrict ourselves to n with 0. Although we're restricting ourselves to integers bigger than 2, so it doesn't matter whether 0 is an even is a.
Well,
Oh, he's another one.
well,
Is
and
0
of
an
course,
even
there's
number?
another
you're
school
not
of
gonna
thought,
find a
right,
solution.
that-
Yes.
Yeah.
Zero.
And there's the, in my opinion, kind of wacky point of view. There are only finitely many natural numbers, in which case there would have to be a solution or not.
There are only finitely many natural numbers.
These finite.
Ultra finitist?
Yeah.
Are you an ultra finitist, Jim?
Absolutely not. I'm pro-choice.
Oh, never thought about this continually. So. If there are only finite integers, there are no counterexamples because we stop at 3, because that's the biggest the crows can count.
Well, some can get to 4.
Some crows can count to 4, but they are not usually qualified as mathematicians, even though they're that good. So I want to talk a little bit about my favorite columns that Martin Gardner wrote, because a few of them stick out. And I want to tell you about a couple of pieces of math that Martin Gardner, I don't think was aware of, but would have liked. So let me tell you about a read and write paper. At the conference in 1985, I ended my first year in graduate school, and I was sitting next to somebody I'd known when I was in my year as a master's student a year earlier, and I hadn't seen him in a year. Hey, Colin, how you doing? I'm doing well. Let's sit together in this talk. So we're sitting in a talk about randomized algorithms for 3 coloring graphs. 3 coloring is a classic example of an NP-hard problem, an NP-complete problem, in fact. So if you can come up with an algorithm to 3 color graphs sufficiently, you can come up with an algorithm for any NP-hard problem. This is an amazing result. One of the biggest problems in mathematics and computer science is P equal to NP? Can we come up with an efficient algorithm for any NP-hard problem? Either we can do it for all of them, we can't do it for any of them, any of the NP-complete ones. And factoring is known to be probably not as hard as NP-complete. So it's not a surprise, it is NP. So you can do it. If you can 3-color it, this is not a surprise. Colin said, yeah, if you can factor, if you can 3-color, you can factor. And I said, I'm sorry, what? Push can. He said, no, this is a really neat way of doing it. What you can do is you can build widgets. And when you 3-color these widgets, they act as gates. And gates, or gates, not gates. And if you can build gates, you can build adders. And if you can build adders, you can build multipliers. And if you can build multipliers, you can build a graph and force some vertices to be 1s and 0s by connecting them to a 3rd color star. And you force these to be 0, 1s, and you've got this adder and multipliers, and that forces these vertices to be the product. So you can build a multiplication graph where if you 3-color the graph, these are forced to be binary, these are forced to be binary, and the product of these is that. And then you just run it backwards. You 3-color you force the product to be a particular value, and you force these to be 0s and 1s, and you 3-color it, and if you can 3-color it, these will be factors of that. And I came back to Waterloo in Glasgow, and one of my professors, Ron Reed, said, did you learn anything interesting in the conference? And I told him about this conversation I had with Colin. And they wrote a paper about it. With the beautiful result that if anybody says, I have an efficient 3-coloring algorithm, they have a way of saying, here is a graph. It corresponds to this number we don't know how to factor. 3-color this graph. And if you can, That will prove that you have it, sorry, that will demonstrate that you have an algorithm that is better than we know how to do with factorization algorithms. So this is sort of a proof that your algorithm works, or rather, when it doesn't, it's a demonstration that your algorithm isn't quite as good as you thought it was. The point about this is really a paper about arithmetic, and it's by Read and Write, so it's a read and write arithmetic paper. It's a very nice paper. So Colin's website is on solipsys.co.uk, and he has a very nice blog post about this. The paper is almost impossible to find. It's in a very obscure proceedings of a conference that I've never been able to get my hands on. But Colin has subsequently written up nice expositions of this, and I commend it to you all. You ever get a chance to see Colin give a talk? Jump at it. He describes himself as the weakest student Bella Bolovash ever had, and the most successful student Bella Bolovash ever had in his own realm. He does optimization of shipping stuff and has been incredibly successful. He's also a very engaging recreational math lecturer. He will tell you how to measure the distance to the moon with a ruler and a pendulum and a stopwatch, or how to gaze out of an airplane and estimate how high you are flying by the fact that you cannot see a sharp shadow of the plane on the ground, or various things you didn't know about triangles. And he's probably my favorite example of a modern day expositor of recreational mathematics. He's one of the people who popularized MathStram. Anybody heard of MathStram? So MathStram is a monthly gathering of nerds, like-minded individuals who get together in a place that will serve them a brew, be it coffee or beer, and discuss some fun mathematical topic, typically recreational in nature. For the last year, we've had a regular MathStram in the Clemson area. We meet in Pendleton at Brews at the Square, which is on East Queen Street, 7 o'clock next Tuesday. It is always the penultimate Tuesday in the month, which is about as inconvenient a date as you can get, because nobody knows how to program that on their calendar. Third Tuesday of the month, easy. But if anybody wants more information about that, get in touch with me, Calkin at Clemson.edu, and I can give you more information about that. Last time, Ben did a wonderful presentation on tangles and twisting ropes together and how you can actually understand what the heck is going on. We're not sure what we're going to do Tuesday yet, but I'm sure it'll be fun, and I hope to see some of you there. Thank you for your attention. Thank you.
I think it was something else's.
It was. You responded so well.
Derail. I had mentioned that.
Oh,
I think I spent it on Tuesday.
Brian's trying to get out of it.
Right, not getting out of this.
Like how we went from lecture, I think it was really good math book talk, so we got a lot of good
You gotta be satisfied.
Right.
Deeply unsatisfied.
I said satisfied.
Oh, good.
Good save, Al, good save. I was like, wow.
Good save.
Wow.
Hey, you know.
Hey, I'm giving you a grade at the end of the so.
Oh. It's 1 right hour, I'll be fine.
Is that what 3600?
Yeah, 20. 3600 is the intermediate computation for math majors, which I regard as an experimental math class, which they learn how to program in Sage, and explore open questions.
Save rocks.
Save rocks.
Any other
No, that
questions?
door is not one.
Did you find out about the crows?
How did I find out about the,
About the crows.
where did I first hear about the crows? That was probably the Martin Gardner column. It was in a column of the nature of the Martin Gardner problem column. It's quite possibly somebody who took over from writing the columns. He cut back on the number of columns he wrote from 1980 onwards. His last column was 1986. And a few people wrote columns with the same title, Mathematical Games, in that 6-year window. He wrote some of them. And then Douglas Hofstadter, who wrote Gödel Shabbat. If anybody read Gödel Shabbat? Wonderful book. Gets everything slightly wrong. Every expert in any area of what he writes about says, well, I like the rest of the book, but the bit I know about, he gets wrong. But he gets it wrong in such a way that he tells you truths. And you end up thinking you understand things a little bit. And that's always good. Well, usually good. So he took over, and instead of mathematical games, he did metamagical themas, which is, of course, an anagram of mathematical games. And then I forget what Ian Stewart wrote about. He continued doing mathematical things, and I just don't remember what title he had for his column. There have been 4 or 5 different people who have followed his good work. I haven't checked Scientific American in recent years, but it would not surprise me if there is still some mathematics column. The mathematics column happened by accident. Martin had met some people at Princeton who he loved paper polish, origami, and things like that. And the inventors of flexigons showed him flexigons, and he wrote it. He said, "Can I write a column about this?" He sent it in as a one-off column, blind, to the editor of Scientific American, who said, "Oh, I'll take a risk on this." Published it in the December 56, I think it was. And they got so much mail, positive feedback to that issue, that he was asked, "Have you got enough material that you could do a regular column on this sort of stuff?" And he giggled, had a chance, and said yes. And he ended up writing almost 300 columns for Scientific American. So, yeah.
That's super cool. I love hexaflexagons.
They're wonderful, aren't they? Anybody made hexaflexagons? Maybe you could lead a math club in how to make them.
And there's one that was made out of a tortilla. I should do like a food themed one.
Have you ever cut a Möbius strip from a bagel? You take a knife, you insert it vertically, and as you go around the bagel, it's vertically in the opposite direction. As you go around the bagel, it's back up again, and you get a Möbius band.
My problem is that I really like to.
Everybody needs it. It's running around the bagel, and you can open it out and toast it.
Yeah,
But you can do this. I have done it.
that's super cool.
Other questions? You know, comment, talk about, Heritage Publishing Paper after he died. I heard a story in grad school, I don't know who it was, but apparently there were these 2 mathematicians that were very good friends. Say like an algebraist and ologist. They used to go to lunch every day and they'd eat, you know, they're just buddies. Well, the algebraist dies and the topologist is working on some big problem, work, stuck. And so one night he goes to sleep, and in his dream, he's eating lunch with his algebraist friend. He says, "Yeah, I'm working on this problem." The algebraist says, "Have you tried such and such?" But he wakes up the next day and tries it, and it works. And apparently the guy insisted on having his dead friend as a co-author. And I guess he had enough clout to get away with that. Maybe the estate didn't, but that's a good way to appear on paper, isn't it?
But Heritage published
Except all beats.
a good number of papers. I don't know how many co-authors he had in total. I do know that when he died, he had 492
492 what?
collaborators, people who've written
Oh,
papers.
right.
It's now well into the 500s.
Yeah.
I happen to know there were 492 because 492 on the list on the day he died was one, Neil Calkin. I was the most recent person to have published and been added to the list. There are others who published more recently, but they have not yet been added to the list that Stan Grossman
And at
maintains.
the other end of the spectrum, there was some guy on that side that years ago, I mean, I don't even remember what the guy's name was, but somebody told me about it, I looked it up. And he had something like 700 papers, and I think 699 of them were simply authored, which is kind of the other end of the spectrum. Okay,
Were they any good is the question.
I think that's a good question. It
Because
wasn't-
Archimedes Plutonium put out a lot of papers.
Right, right. I get what you're saying. Rule of Math Club is all the pizza's gotta be on, so take it home, be the hero of your dorm, whatever. Stay tuned for next week's Math Club, it should be a good one. Y'all have a great weekend, and we will see you on, well, next Friday. Let's say speaker again. You're a collector.
That guy. They're gonna make a